All right, so part two. Part two is when we started looking at single variables to sort of just see what was going on with them. So there were two parts to part two. We had our like numeric and our graphical stuff, right? So numeric wise, this is when we talked about, say, mean and median are measures of center, right? So, and we talked about our standard deviation and our IQR, which were our measures of spread. And we talked about we should be using mean and median when we have symmetric data, median and IQR when we have skewed data or data with outliers. And we had that little table sort of telling us what to use when. That is still incredibly important. When should I be looking at what measurement? Right? If I give out the average home price in San Diego, that's not a really good measurement because there are some really, really high priced homes that are high outliers and going to cause that to seem a lot higher than it is. We should be using median to give a more accurate representation of center. Remember, we also had all the ways that the whale tail, right? Where what's going to happen with those high outliers. So the high outliers in terms of prices are going to pull the mean over, while the median will stay roughly in the center of our distribution. It's not going to be perfectly on the mode. It will get pulled over a bit, but not as much as the mean where we add everything in. So that whole whale tail example that we had in class. So you could definitely still see that, right, from before. So that's most of it for numerics. There wasn't a whole lot more. I mean, I love to have questions about what will happen if I delete this observation or if I add an outlier to each of these different measurements, because I like to see that we understand how we calculate them. And if I say, what if I change this 5 to a 50? We should all know that the average will go up. And then the median, it would really depend where that 5 ran. So as long as you really understand how to get all of these, the IQR, understand that it's the middle 50%, right? The range of the middle 50. And you can see it on the actual box plot. Your IQR is this range from the front of the box to the back of the box, from the Q1 to the Q3. And then our standard deviation, remember this is our how much everything deviates from the mean. And this was all about our normal curve, right? Everything should be within 3 standard deviations of the mean, 3 little bunny hops. So having a good understanding of those two different measures of spread is something I really hope that we have by now and will probably ask questions about. In terms of our displays, you could definitely see some examples where I just give you box plots or histograms, whatever it might be, and ask you some questions about them, whether it's free response or multiple choice. The big displays that we went through were histogram, box plot, and then we did stem plot, but those are a little bit silly because they only really work for a small data set. So those were our big 3. And for all of this stuff right here, we're talking about quantitative data. Everything here is quantitative. I have to have numeric data in order to take an average or make a histogram and all that. In terms of the displays, more stuff you could be asked for, right? Just remember the histogram is where you can see our shape, which is our center. Oh, well, more than the shape. We can see the shape, we can see the center and the spread. And then the shape itself was the symmetry, modes, and outliers. There's a whole lot we can actually talk about in terms of a histogram. And then the box plot, this thing involves our 5-number summary. And we can grab all those little percentages off of it, right? So I could say what percent are more or less than some value. We can still see whether something is skewed or not. And the stem plot is very similar to a histogram. So, but these are the 2 big ones, the histogram and the box plot. What else did we do in part 2? Well, another thing that we did tackle in part 2 was a contingency table. Right, how do we look at 2 variables, categorical variables together? And we could ask all sorts of percent questions. What's the percent of females who have been majoring in business, or what percent of students are female and majoring in business? So maybe go back and look at that driver versus type of car question from part 2, because it's a really good example. We covered z-scores, which seems so basic now that we've done so much, because our z-score is the quintessential test statistic, essentially, right? We've been seeing this, whereas I've been talking about our observed minus expected all over our variation, right? Same idea, except for our z-score, this was our what did we observe minus the average, which is what we'd expect, divided by our standard deviation. So I don't see a question where I just have you calculate them, but I could always put something in there just making sure you understand that our z-score tells us how many standard deviations from the mean you are, I suppose. I'm trying to think if there's anything else from part 2. I'm going to write this final, I guess, next week, because I haven't written it yet. But I think that's pretty much it. I mean, we talked about outliers. There was the time plot thing. There's the empirical rule. But the empirical rule is silly once you do the normal distributions. I think this is it. Displays and numeric measurements. That's all.